Well, hello, everyone. My name is John Peppers. I work as an engineer on the Xamarin Android team. Yesterday, I gave a talk that was kind of like, here's a high level of how you use Xamarin Android. Today, I'm going to actually build Xamarin Android from source. And I'll even show a little bit of like what actually happens in your app when it starts on Android. I think that's interesting, and it's something that I've not seen out there. Like, there's not a talk about this. So let's kind of get into it. So why would you even want to like mess with doing this at all, right? It seems pretty complicated, maybe scary. But the main reason I think is to get a deeper understanding of the Xamarin platform and the Xamarin stack, to understand like what even happens, like how does mono work? These kinds of questions I think are helpful as a developer. Another thing might be that you want to fix a bug that is important to you and your project, but maybe it's not affecting lots of users. Maybe you're using this little corner of Xamarin, and you just need to fix this one line of code in Xamarin Android. Well, you can actually do that. We're open source. And the other reason is just to get experience, right? I know if I saw a resume that had links to pull requests on it, that would be a pretty good person to hire, right? So let's get into it some. The next thought you might think, like, hey, can I actually change Xamarin Android? Do I need superpowers? Like, do I need to be like the developer equivalent of Terry Crews? Or can a normal person do this, right? And I don't think you have to be that. Like, when I started, I didn't even imagine how this stuff works. So it's definitely achievable. So when you build Xamarin Android, obviously it builds C# code, but there's also Java code and native code. Mono itself is actually written in C and C++, but it's portable, where it'll run in all these places, like mobile devices, WebAssembly, that kind of thing. And we're going to build code not for one platform, but code that runs on Windows, Mac, and Android devices, you name it, right? So it's kind of a complex, all the things that are going to happen here. So in this talk, we're going to use the command line quite a bit. And you can also use Visual Studio. But I think this is going to get a deeper understanding of like how us as the engineers on Xamarin actually work day to day. So I'm going to kind of do what I would do sitting at my desk, working on Xamarin Android. We're going to use MS Build, which shouldn't be scary. It's what you do, what happens when you hit build in Visual Studio. It runs MS Build. And I'm going to be on Windows. I know there's a lot of Macs around here. But every command I run, you can actually run on Mac too. You just use make instead of MS Build. And then we have a tool called XABuild, which I'll get into later, that we'll use to build apps with our build of Xamarin Android. And then we'll use ADB quite a bit, which stands for Android Debug Bridge. And that's just a tool that lets you like interact with an Android device or emulator that's connected. Right, so before we get started, before I get into the demo, you'll need a few things on your machine. Obviously, you'll need like Mono or .NET. You'll need Visual Studio or some kind of code editor. Like, you don't have to. You can use VS Code. You don't have to use a full IDE. You need Java, and you need the Android SDK and the Android NDK. And some of these, our build, like it downloads and installs them for you. But it's always important to make sure you've got these things installed. I'll get into that. So Mono, if we think about Mono, right, we're going to have to build Mono, right? And it's going to target all these different Android devices. Right? And we also need to build Mono for Windows and Mac, which sounds strange, but the Android designer actually runs Mono inside of it. And we build them in debug and release. So that's 12 Monos. That takes a while, like hours. So we don't want to do that, especially when you're developing Xamarin Android. We cache builds of Mono on our CI system, and we download this like zip file and unzip it, if you want to think of it that way. So that's all the presentation. I'm going to actually, let's do some of this stuff. And hopefully it's not going to be like watching paint dry. There's going to be times where we're going to have to wait 30 seconds or something, and hopefully I have some good jokes, or you can just look at me, whichever. So the first thing I want to show, we good? Yeah. So we're on GitHub, right? If you didn't know, Xamarin is just on GitHub. Xamarin Android is at Xamarin/Xamarin-Android. If you want to define Xamarin iOS, it's Xamarin-Mac iOS. And we do all of our development just out in the open here. If you're wondering about a new feature, like, for example, Android app bundles, like you could probably find the pull request where we did that work. And you could even like find out what we're working on if you just like click on the pull requests. So this is great. There are a few things that are not open source. For us, the main feature is fast deployment, which isn't a big deal while you're working on it if you're trying to build Xamarin Android yourself. But I'll show some details about that as we get into this. Let's go to the next thing. Oh, OK. So I'm going to use the new Windows terminal, which is pretty cool. It just came out, and you can just get this from the Windows Store, but you could use your favorite command prompt, whatever you would like to use. And the very first thing that we want to do is make sure that you can actually run MS Build in your command prompt, right? And you could do that by just putting MS Build like in your path. That's one way. You could also use like a PowerShell alias to do that. If you're into PowerShell, if not, you can just use a regular command prompt to do this. But all you want to do is be able to run MS Build, right? And so the very first thing that you'll do if you want to build Xamarin Android, right, is you're going to run the prepare target. And so on Mac, instead of typing MS Build, this solution, prepare, you just type make prepare. And it's going to do the same thing. And what this is going to do is going to check that your machine actually has all the right software to build Xamarin Android. And this is going to take a little bit. This is probably the longer step. But some things it's going to do is there's quite a few Git submodules, if you look in here, in this external directory. So we have Mono as a submodule. We have all these different things that you may not want to get into the details. So that's part of what's going on here. We also have, it's going to restore NuGet packages. We use a few NuGet packages in the product. Let me see what else it is. It's also going to download that Mono bundle that I talked about earlier and put it in a directory and unzip it. It's also going to download the Android SDK and NDK. Now think about like what we work on. So Android Q is coming out, right? Well, if you want to use Android Q today, you have to download a beta of the Android SDK. And that's why it's very important for our build to be able to install a specific Android SDK on your machine. So my machine probably has like 2 or 3 Android SDKs on it. So it can get a little confusing. Yeah, I ran an ADB. Which ADB was it? So hopefully we don't get into that. It's almost done. This is the very last step. I could show one more thing while that's going. So we extract files into, there it goes, an Android toolchain directory that's just in your home directory. And this is where our build puts stuff. And you can customize that if you want to put it somewhere else. I'll show how to do that in a minute. So let's see, what's the next thing we could show here? So let's just actually build it now, right? And instead of running that prepare target, we're just going to run the build target. And since build is the default MS build target, you can just run MS build in the solution. And the equivalent on Mac is you would just type make in the current directory. Yeah, go ahead.
We had a decent machine yesterday, so 4 cores, 16 gigs, about the minimum. I'm trying to build iOS or...
So yeah, the machine I have at home is a desktop, and this laptop is not anywhere near powerful as my machine at home. But you could certainly do development on a reasonable machine. Right? I think the main thing you need.
What's reasonable?
Oh well, yeah. He said 4 cores, 16 gigs of memory. I think that'd be fine. Yes. I think the bigger thing is having enough hard drive space. Like if.
Can you pare down the builds at all? So if you only wanted to build, so I'm on the Mac, I'm doing Android, let's say, and I don't want to build all the other targets. I want to build the other ARM targets or anything else.
Right, okay. So he's asking if this build is pared down, and this build is actually already pared down. Okay. For example, in the top of our repo, there's a configuration.props file. I hope that's showing up. This is all the settings for our build are in this file. And one thing you could notice is that, where is it? Here it is. So we build for 3 processor types by default, and these are the most useful ones: ARM v7, ARM 64, and x86, just so that you could use an emulator if you like. Now, you could remove some of these. We also had just regular ARM ABI there, and we also had x86 64 there. You can add those. The other thing we have is we only build the latest stable framework version. So if you've ever looked in a CS project file, there is a target framework version. You can change that to 8.0, 8.1, 9.0. Well, that would be building mono Android DLL like 10 times, and you don't want to do that. So we just build the latest stable one, v9.0. So let's see how far it's getting. Hey, we're done. That was good, right? Only 4,000 warnings. And the reason it's that way, if you think about the Android APIs, how many there are, they don't comply with the C# naming rules, right? So many of these warnings are, you can't name a type the same as the namespace. Well, in Java, they did that, right? So that's why there's so many. And a lot of it is just a history of Xamarin. If 10 years ago they shipped mono Android DLL for Android 4.0, we can't actually change the types in there or we'll break people's projects. So some of the warnings from back in the day are just going to hang around in the product. And you guys, I mean, you just want your app to work. You don't care how many warnings we get when we build Xamarin Android. We're done. We built it. Now, it's going to take a little longer than what I just did here. This took 2 minutes. If you're doing it from scratch, it'd probably take 15 minutes. So it's not horrific, but it's going to take a little while. So now that we've built this, what did that actually do? Let's look. Our output directory, I'm going to zoom, is bin, right? And there's a few directories here. Bin debug is actually the output of our product, where it built into. Build debug is any intermediate stuff we need to do to set up the build. And then test debug is where any test output appears. If we look in here, this is kind of the directory structure of Xamarin Android if it's installed on your machine. Let's look at this first one first. I talked about mono Android DLL, right? What actually is that? You've probably seen it in your project. It is actually the binding of all the Android APIs, right? You think of today you can create a Java binding project that has some Java library that you want to use from C#. Well, Mono Android DLL is like the mother of all binding projects because it's every Android API is in there. And we just built that on my machine just now. So we notice here there's only a v10 and a v90. v90 is the latest stable. And we think that Android Q is going to be 10.0. So here in a few weeks, we might be building 10 by default. We'll see what happens. And then v10 is going to have like just the .NET BCL for any Xamarin Android app. If you want to use system net HTTP, that's where this library is. And these actually come from Mono, right? These were in that bundle that we downloaded earlier in the build. So another interesting directory is where all our MS Build stuff lives. Let me go in here. So all of the tooling that we may need to use while building people's apps are in this directory. So for example, you see here's apt2. I spoke about that in my talk yesterday. These are where if we have to redistribute like open source products from Google, this is where we put them. Bundle tool is in here, and that allows you to generate app bundles. And so all the nuts and bolts and the pieces of Xamarin Android are actually in this directory. Like, let me find another important one. Xamarin Android build tasks. This is actually the bulk of like all the work that goes into building an app is in that assembly. And the MS build targets are in here too. These are the text files. All right. So let's do something a little more interesting. We have a tool called XABuild, right? And what does that do? It is MS Build, right? It configures MS Build to build an app with what we just built on our machine, which sounds a little crazy, a little weird. So in our repo, there is a Hello World app. Let's just go look at it a little bit. In samples, Hello World, and main activity, right? We just have this in here. This is very similar to the template you have right now in Visual Studio. It's just you click a button and it has clicks, right? So let's build that app. And just to make sure, I should have done this before I got up here. It's not tabbing. I'm just gonna clean that directory because I don't know what was there. And so now you think to yourself, okay, how do I know that I'm using my Xamarin Android, and how do I know I'm not using the one that was installed with Visual Studio? I'm going to show you I shouldn't have cleaned. Anyway, I added a switch called /BL. And what that does is it makes a new type of logging that MS Build has. And we can actually dive into that log, and we can find out more about what happened there. See, it created a msbuild.binlog file. And there's a viewer for this type of file that you can get for Windows. You can actually open this type of file in VS for Mac, and it's also pretty useful. But I'm just going to look at a thing that I know is in here, right? Resolve SDKs. This is an MS Build task that finds the paths to things. And notice right here, here's the assembly it came from. And that path is in C/source. That's where I have all my code checked out from GitHub. So this is a good sanity check to know, hey, I'm actually using the Xamarin Android I just made. And if this pointed to program files Visual Studio, you would know that you didn't do the right thing, right? So let's see, what's next? Right, so what am I going to see here? I'm going the wrong place. In this bin debug directory, there's just the DLL in there. Has anyone noticed that when they build a Xamarin Android project, there's no, where's the APK? Right? What does that happen? Well, it doesn't actually get built until you deploy, right? But we can do that. Let me make sure I get rid of that clean command I put here. We have a target called sign Android package. I'm just going to add on the end here. And what this does is it creates an APK and signs it with whatever default key store you have set up. So it should skip most of the work, and you can see right here it's just signing the APK. So let's look in there now. We have an APK file. Great. It is 64 megabytes. Does anybody know why it's so huge? All right, that app was, yes, 3 ABIs. It also, and not stripped. So we don't have fast deployment because that is not in the open source part of Xamarin Android. So the whole .NET BCL is in that APK. So let's look what's in it. I have 7-zip in my path, so you don't have to know that, but you can see here's actually what is in that APK. See, look at the assemblies directory. It has every system, everything, right? So let's build a release build. What's the difference there, right? All I have to do is add configuration release, and it's going to build from scratch. This might take a second. But this is actually going to run the linker, right? And the whole BCL is going to be stripped down. This is going to be the same as like a release app that you would submit to Google Play or whatever. And we're there. That one too bad? We want to look at the release directory. And see now instead of 65 megs, it's 7 megs. And that's pretty reasonable for a Hello World app. Let's look inside it though. You can see there's a lot less assemblies. And we actually only have 2 ABIs in this build. And this is kind of the anatomy of an Android app, right? We have native libraries. We have .NET assemblies. We have a classes.dex file, which is all of the compiled Java code is in that file. And if you had multi-dex on, you would have a classes1.dex and a classes2.dex potentially. They're really good at naming things. You also have images in here as well, and your Android manifest at the very top. So this is kind of what all comprises an app. So let's do something. Let's install it, right? Has anyone ever used ADB before to do things? Yeah. So if you've ever used ADB, it's not that tough. For example, the command is ADB install, right? And I'm going to install the signed one where it wouldn't work. I have a device here. Let's see if it. And I'm going to use a tool called Visor to show my screen here. Hopefully this works out. Hello. Okay. Hello world. Right. So we just built Xamarin Android, and then built an app with our Xamarin Android and installed it, right? Now, you may not want to use ADB to do that, right? But let's say, for the sake of just showing things, that app is com Xamarin Android. Oh, it's on the screen. Hello world. So that uninstalled it. And it actually like closed the app on the phone, which is kind of cool. You see it just flash away. But we can also run, instead of an instead of ADB, we can run the install target to do the same thing as what I just did. I'm going to do the release one. It's smaller. It should work. So this is the same as running ADB install, just using our MS-build stuff to do it. And it did appear on the device, but I don't want to pull it up again, right? Not much to see there. So let's do something interesting, right? Let's change Xamarin Android. And I had a thought, what if we hid an Easter egg in everyone's APK, right? We just we just put like an image in there. Now that seems pretty funny, right? Let's look, I'm going through code. I just want to show the image that I was going to use. Here it is. It's called secret.png. And that would be pretty cool if we just stuffed it in every APK, right? Let's see if we can do that. So here is a portion of, I should have taken this out of dark mode. I think you can see what's happening though. Let's write some code. So this is a build task called build APK, and it takes the APK that apt gives us, and we have code that actually appends to it, right? And it's just, an APK is just a zip file. So it's actually not that hard to construct your own APK. It's just not something we think about. So I've added that funny image as an embedded resource in this project already. And I'm just going to pull it out. It was called secret.png. It was so secret, right? And we're going to go apk dot, and this is our code, right? I think it's called archive, yeah. Add entry. And let's just call it secret PNG, right? S. And then we need to call apk.flush to put it to disk, right? So that's all we did. Not that much code to do live. Let's find out what happens. So what do we got to do now? I changed Xamarin Android. We have to build Xamarin Android again. And I'm just going to hit up. There we go. MS build Xamarin Android solution. And then we got to wait for, this should be 30 seconds. And I should think of a joke. It's chilling. I think I could tell the dad joke. What about that? Yeah. Does anyone know why the Scarecrow won an award? Because he was outstanding in his field. Oh, come on. Hey, it's done, 37 seconds. Okay. So now what do we got to do? We got to rebuild the app that we changed, right? And let's just do the debug one. Where was that? Let's just hit up a bunch. And let's play it safe and clean that directory. It would probably have worked, but I'm on stage. I don't want to mess with it. Right? So what we should see here, hopefully, if things work out, when I run that 7-zip command, that image will actually be in the APK. So after we do this, you guys should watch for PRs and make sure I don't actually do this. Right? No one would approve it, so don't worry. 7-zip, right? We want the we did the debug app, right? Let's make it where I'm going to use select string is just like grep, but in PowerShell. So let's look at all the PNG files. And see right there, in the top of the APK, I hid secret.png. We have the actual image. We just stuffed it in there. Every app would have that image in it. This isn't particularly useful, but that's what we did. So another thing I think would be interesting here is let's go through like what actually happens when an app starts up. If we look at that Hello World sample, has anyone ever looked, just out of curiosity, looked in this OBJ directory to see what's going on? There's a lot of stuff in here, right? But the most important thing is there is like the full Android manifest file. The manifest that you create for your app is very small, but we actually had to generate a full file with all this stuff in it for things to work. Like nice things that we have, like you can put uses permission in your C# code and like put the permission there. Like our build actually has to put that in here for it to work on Android. So there's some things in here. So the main activity we looked at earlier, that's where this is defined, right? This is how Android knows which activity to start. first, right? And the most interesting thing we're going to go look through here is the mono runtime provider. Has anyone heard of what a content provider is on Android? It's kind of a lesser known feature. But what it does is it lets you run code in an app before the first activity starts. Now you think about that, who would need to do that? Well, Xamarin needs to do that. We need to start mono, right? However that magic works. And we need to load all the .NET assemblies and like get C# ready to run. And so that's what we're doing here. The mono runtime provider is just a Java, it's just Java code, right? And we have to be Java code, it's Android. So this is the very first thing that gets called when your app starts up. And we don't need to go through everything here, but this attach info method is an Android API. So you see here we extend content provider. This is just part of Android. So let's go to the next place. There's a little code here that makes app bundles work. But let's go to the next place here, this load application manager. Yeah. So the next thing going on here, we eventually have to get into native C code because Mono, its APIs for starting up Mono are C APIs. However, once you're in C code, it's hard to call back into Java. Like, if you think about, like, on the screen, we have to do things like figure out the user's locale, their current language, a couple directories. Like, to try to call back from C to get that information is kind of complicated. So it's easier to find out this data in Java, go into C once, and then start Mono. And so that's what's happening here. We're loading a few libraries, and then we call runtime init. So we're going to go to another Java file. And here's runtime init. But what is it? What does it do? It's got a lot of parameters. What does it do? It's just empty. Wow, that's weird, right? Does anyone know what native void does in Java? Well, this is the same as if you think about DLL import in C#. You could have like public, static, extern, void, and call into native code. Yeah, this is the same thing, but Java has their own way of doing it. So we're going to call into C. And now this is starting to get scary. But this is the entry point into C. And I don't think it's going to be helpful to like go through this code, but I think it's helpful to know like what's actually happening here. It's calling Mono's embedding APIs to start Mono, load .NET, load your assemblies, and then your C# code works, right? It works. Let's change this code. Is that scary? I'm going to copy paste because I don't know. It seems a little scary to just live code C on stage. So let's just do something like, okay, log_warn. That's the Android API in C. If you've ever used Android util debug.warn, or no, log.debug, log.warn. This is the same thing, but you're using it from C. And we're just going to say, John Peppers is great, right? And we're going to go build again, right? Build Xamarin Android. So what did I do? I changed code as Xamarin starts up inside an app. So to see the line I just changed, we're going to have to build a new app, deploy it, start the app, and then watch the log. We'll see if it works out. This, again, I don't have another joke. Oh, this isn't going to be quite as long. You can see there it's building some native code, which looks scary, but it should be done any moment. Hey, okay. So we're just going to run that same command again. But instead of sign Android package, let's just go ahead and do install. and we're gonna run some ADB commands. We're gonna run ADB logcat. Has anyone ever used that before? It's what tools use. Like if you open Visual Studio, there's a device log. It uses that. There's one in Android Studio that also uses it. But you can also do it command line, which I like because, well, I'll show you how to use it, but you can get the whole log up until your app crashes. And that is very useful for us to, if you need to submit a bug to Xamarin Android, for us to figure out what's going on. So I'm going to run ADB logcat-c, and it, when you use visor, it does something weird there. But all that did is it cleared the log on the device that I have attached here. And I don't need to show you this device anymore because we can actually just interact with it with ADB right here. So if you run ADB logcat, the device is logging stuff right now. I don't know what it's doing. That's the accelerometer. I didn't do anything. The OS is doing that, right? But if we launch the app, whoa, look at all that. I'm going to close, stop it. But how are we going to even get that? I'm going to do a -D, and that just dumps the output again. And I'm going to use that select string. And let's just look for the word John, I guess. Hey, we did it. So we changed some C code, and we logged John Peppers is great, and it worked. Okay. My beard did not burst into flames. Okay. So what else could we look at here? One last. Let's do one other thing that'll kind of blow some minds, right? Let's change another MS Build task here. That one I showed earlier, resolve SDKs. And this is going to be a little crazy, but let's say we just wanted to log an error here, right? And this is MS Build's API, where that logger there is somewhat complicated, but it's just going to log in MS Build's world. This is how you log. And so this one is John Peppers is not so great, right? Because we're going to log an error. Right? So what's going to happen if we built an app using this code? It's just going to error and stop when this task runs, right? But if you want to crudely debug an MS Build task, this is one way to do it. You can actually log messages, which might be more useful. So this should take another 30 seconds. And I don't know how to, I should have changed our build to make it quicker for demo purposes. But, I mean, it's hard to do. There's so much going on. So what's going to happen? I saw some red. Is there going to be red here? Right. Xamarin Android, we have to, this is crazy. So we have some projects in here, right? We have Xamarin Android NUnit Lite. We have OpenTK. Those use Xamarin Android. So we have to build parts of Xamarin Android, and then our build uses the parts we just built like the whole way down. So we can't actually build an app anymore. We actually can't even build ourselves because we broke it on purpose, which is why I wanted to show this last. But the error, yeah, the error says John Peppers is not so great. So, I think that's all I have to show. This is a really scary demo for me to do. So if there's any questions, I think we can stop here. I wanted to kind of leave it open because I can go show parts of Xamarin Android if you're like, hey, how does this thing work? I can go open this right now and just show it. And I think we have a mic right here if anyone wants. Just any question. Oh, do you have time? Okay. So we don't have enough time, but I'll be at the back. So if you want to talk to me later, I'll be here the rest of the day. But thank you, guys. I hope it was helpful.